In this video, we'll look at question 53 from the specimen paper. So in this question, we are supposed to find the total length of intervals for which all of the following three conditions are satisfied. First of all, x needs to be between 0 and pi. Tan of x between -1 and 1, and sine of 2x must be greater or equal to 1/2. Now, two of these inequalities involve trigonometric functions, so it would be a good idea to try and draw the two graphs of the two functions to help us understand what's going on. You can stop the video now and give it a go yourself. So first of all, the interval which we are interested in is from 0 to 2 pi. It's this interval here. The first function is tan of x, which starts at the points 0, 0, then goes up and approaches infinity. As x goes to pi by 2, there's an asymptote at pi by 2. And a similar thing happening on the other side of this asymptote, except this time to negative infinity. So that's one graph done, and how about sine of 2x? Well, we know what sine of x looks like, a bit like this. So it starts at 0, goes up and down. The period is 2 pi, and it crosses the x-axis for the first time at x equals pi. But remember that our function is sine of 2x, so this whole function will get squished by a factor of 2, and will look something like this. Well, almost. It should still go exactly from -1 to 1, but go up and down twice as fast. So, and as we can see, it completes one full cycle in exactly pi. So we should draw a sinusoid of one cycle in our interval, like this. And now with this graph at hand, it will be much easier to decide which inequality is true. So let's first have a look at the first one, and that is trivially true for the interval from 0 to pi. That's the entire interval which we have drawn, like this. So that's one done, and on to the second one. So tan needs to be between -1 and 1. So let's draw the lines of y equals 1 and y equals -1. And as we can see, the red graph is between the two lines for two parts of the interval from 0 to pi. Right here is one, and the second one symmetrically at the other end. And as we know, tan of x equals 1 for x equals pi by 4. So this point here where the two lines intersect has to be at x equals pi by 4. And then by symmetry, the other point of intersection, this time with y equals -1, with the other constant function, has to be 3 pi by 4. That's just 2 pi minus pi by 4. And so those are the two intervals for which the second condition is satisfied. And now for the last one, which says that sine of 2x, our blue graph, needs to be greater or equal to 1/2. So if I draw the line which corresponds to y equals 1/2, like this, I can see that part of the blue graph actually is above this line. So this will be our interval for which the third condition is true. So let's draw it in from about here to there. But we also need to find the numeric values of where the interval begins and where it ends. So why don't you give it a go yourself? So one thing we know for sure is that sine of x equals 1/2 when x is pi by 6. And what that means for us is that sine of 2x, our function, equals 1/2 when x was pi by 12. When we multiply this number by 2, plug it in, we should get 1/2. So that's pi by 12 at one end of the interval. How about the end of the interval? Well, again, looking at the function, we can solve that by symmetry. The distance between 0 and this point needs to be the same as between pi by 2 and the end of the interval in question. So our interval ends at pi by 2 minus pi by 12, which equals, well, I'll have to multiply top and bottom by 6. This is 6 and 12. 6 pi divided by 12 minus 1. Pi by 12 is 5 pi by 12. And we can write that in, 5 pi by 12. So let's go have a look at what the initial question was. We're supposed to find the total length of intervals for which all of the three conditions are satisfied. Okay. So we'll have to find the intersection of these three intervals and the length of that intersection, and that will be our final answer. So where do all three of them hold true? Well, here in this region, which is from pi by 12 to pi by 4. And how long is that interval? Well, pi by 4 minus pi by 12. We're going to need a common denominator again, so that's 3 pi by 12. We subtract the 2 pi by 12 is pi by 6. And That is our final answer. And in the exam, that was option B.